So today we're going to be starting with functions, which according to me is one of the most important topics in this course. So first we would ask the question, what is a function? But before that, we need to know what a relation is. So, well, as the name suggests, a relation is uh, basically correlating or connecting two things from two different sets, and that could be anything. Like, let's say we had a set X, which was made up of a triangle, a circle, and a square, and a set Y, which was made up of a pentagon, a diamond, and let's say a parallelogram. Okay, and if I just related these together, there we have a relation. There are four kinds of relations: one to one, which is basically any relation which correlates one thing to only one other thing. For example, this relation wouldn't be a one to one because over here we've connected one thing to two different things. A many to many relation is when we relate many things. For example, maybe two things from here to the same thing there, and one thing from here to two different things in Y. So, for example, this square is related to both a pentagon and the diamond, and both the diamond and the parallelogram are related to the circle, and that's why it's a many to many. And from there we can see that a one to many is when one thing from set X is related to two different things in set Y, and a many to one is when two different objects from set X is related to the same object in set Y. For example, here the circle and the square are both related to the diamond. So now where does functions come into this? So all functions are relations, but all relations might not be a function. And a function is anything that takes in an input and gives out an output. And it has to be just one single output. A function is anything that relates inputs to just one given output. And that's why it is a relation. But as you can see, since it's only one output, it can't be a many to many relation or a one to many relation, as it can only relate something to one other output. Functions are those relations that are one to one relations or many to one relations, as two different inputs might have the same output. So now, how do we tell the difference between these relations and functions, or what is a one to one or a many to one function? So now let's say we graph the function by making the inputs on the x number line and the outputs on the y number line. And now let's say I get a function that is something like that. So there is something known as the horizontal line test can differentiate the one to one and the many to one functions between the many to many and the one to many functions. So what we do is basically imagine that there was a vertical line passing through almost every point on this x-axis that was perpendicular to the x-axis or parallel to the y-axis, and we would see the number of points it intersects with. And if any single line intersects with 2 points, for example, let's say if I had this relation, this right? So a vertical line over here would pass through 2 points. So now if any of these vertical lines passes through more than 1 point at the function, it ceases to be a function, as then it would have to be a many to many or a one to many, as over here this 1 point is relating to 2 different points. So one input gives out 2 outputs, and so it can't be a function anymore, it would have to be a relation. And a way to differentiate between the many to one functions and the one to one functions is something similar, except it's a horizontal line test. Yeah. So as you can see, in the horizontal line test in this case, it passes through 4 different points, while the horizontal line test in this case only passes through 1 point. In this case, it is a one-to-one function because it passes through only 1 point each of these horizontal lines, while here, because it passes through more than 1 point, it would have to be a many-to-one function, because as you can see, only one x value corresponds to one y value when it passes the horizontal line test and the vertical line test, while over here, if it just passes the vertical line test and not the horizontal line test, then it has to be a many-to-one function. So now another important thing is the domain. And what the domain really is a set of all the possible inputs that are allowed. Now, this allowed means that there is no mathematical error when we input those values. So, let's say we're given a function that's f of x is equal to x squared plus 2x. We would assume that we are looking at this in a real number line. So, x could be any value that is on the real number line, and there is no mathematical error if we input any values in the real number line. However, if we had something like g of x is equal to 1 upon x, now we know that we can't have the denominator to be equal to 0 at any point. So, well, we would say that this belongs to the real number line because we're assuming that we can input the whole number line, but x cannot equal to 0. Right. And whenever we're given any question in the IB, we would have to assume that we are allowed to put in the real number line and then look at what values wouldn't exist, unless in the exam it has been specified that x can be, let's say, only greater than 0, in which case it would be all the values greater than 0. Or if you're modeling something, for example, in this case, let's say I'm modeling the height of a ball x seconds after it's been hit by a bat, in which case the function of the ball before it's been hit by the bat, as in before x is equal to 0, it would have a different function. So for this, it would only be for x greater than 0 in this case. Right. And so now, to find the domain for those functions where we're assuming that we can input the real number line, we need to keep three things in mind when trying to find the domain of a function. It is that we cannot divide by 0 of log of a where a is less than or equal to 0, and you cannot have the square root of a where a is lesser than 0. We know that these can exist, but just in the form of complex numbers. But we are only looking at this from a real number line to another real number line, and in that case, this wouldn't exist. That's why these three things are giving us a, so to say, mathematical error. And so the domain, we cannot have a domain that gives us an output of any of these values. So when we look at the domain of a function is equal to anything, like let's say it was ln x minus 2 plus root 2x minus 5. Okay, we would have to look at the places in which any of these things could happen. So we have a log over here, and we need to make sure that this log is greater than 0. So inside of the log, we have x minus 2. So we would say that x minus 2 would have to be greater than 0 to find the domain. So therefore x would have to be greater than 2, as anything below where x is below 2 would give us an error, so to say. And another thing that we would have to look at is that the things that are underrooted would have to be greater than or equal to 0. So we would say that 2x minus 5 would be greater than and equal to 0. Therefore, 2x is greater than or equal to 5, and x would have to be greater than and equal to 5 upon 2, which is equal to 2.5. So now we know that x would have to be greater than 2, and at the same time x would have to be greater than and equal to 2.5. So we would say, so obviously this, we can't have something that's 2.3, as there would be an error over here. So we would take the greater value in this case and say that the domain of x belongs to real numbers that intersect with x greater than or equal to 2.5. Now, another very important concept is the range. The range is all the possible outputs given the domain. So if I input the entire domain, what is the range of all the possible outputs that I can get? So a way to visualize that is, now if we had this graph of, let's say, y is equal to f of x, where f of x is equal to x squared. So we would say that, so the domain in this case is x belonging to real numbers. Now the range in this case as you can clearly see, that as we input all the possible real numbers into as x, y will always be greater than 0 because it never goes below 0, and it is equal to it at x equal to 0. So the range is y is greater than and equal to 0. But now let's say, as I told you before, we can restrict the domain if it is modeling something, or in any case, we can restrict the domain. So now let's say I want the domain to be only 2 greater than 0. So now at 2, the value of the function is 4. And since it's never equal to 2, it can never be equal to 4 either. So the range changes from y greater than 4, as we would only be looking at this, which is all the values of y greater than 4. That is one way to find the range. And another situation that you might get is the entire range might not have the same rule, so to say, as the entire domain. So we could say that f of x is equal to 2x plus 5, and for x lesser than and equal to 5, and x square for x square plus 5 for x greater than 5. Now in this case, the function would look something like this. You wouldn't, as of now, you wouldn't need to know how to draw such a function, but let's just assume that this is the function. So now we can see that the range goes from all the way from negative infinity to infinity, and so we can say that the range is then equal to the real number line. So you can see that using the graph of the functions, we can find the specific ranges at different points. Hi guys, I hope you liked the video. I'll be uploading one every week except tomorrow, when I'll be uploading functions part 2. So like, subscribe and share, and press the bell icon to get updates on my channel.